this code example, we're going to take a look at a function that will take a modern color image, such as this picture of the tower that contains the Big Ben bell, and convert it into what would appear to be an old-time photograph that has this brown, reddish, grayish tint to it. And this style of photograph is referred to as a sepia tint photograph, an SEPIA. And so we're able to do this by simply manipulating the red and blue values within the picture. It may be a little small for you to see on the video, but I've got the basic instructions up here right above the sepia version. If the red value in the picture is less than 63, remember the values range from 0 to 255, then we're going to increase the red by 10% and reduce or decrease the blue amount by 10%. If the red is on the high end, the greater than or equal to 192, then we're going to increase the red by 8%, so not quite as much, but we're still going to increase it, and we're going to decrease the blue by 7%. And if the red is in the middle between the 63 and the 192, then we're going to increase the red by 15%. That's the most we're going to do, and similarly decrease the blue by 15%. As we go through it, we're basically increasing the red, decreasing the blue. We're not doing anything to the green value, but by a combination of that increase and decrease of the red and blue, we turn the color photograph into the brown-gray tone that you see in the sepia tint. So let's take a look at the code and see how we accomplish that. So we've defined it, indicated we're passing in a picture, and the very first thing we do is to call our grayscale function to convert our color image into a grayscale image. And it's not shown on screen, but if I scroll up, you will see that here at the bottom, I do have the definition of the simpler grayscale function. We could use either one. I just chose to use the simpler one that we've looked at earlier. So scrolling back up, we call the grayscale function, giving it the picture that we were given as input into sepia tint. It converts that picture into grayscale, and then we start going through every pixel in the picture. Using our usual for pixel in get pixels of picture, we get the red value and the blue value by using the get red and get blue functions. And then we have some of those decisions to make. So we first ask, is the red value less than 63? If it is, then we want to set the red value to whatever it currently is times 1.1. Remember, we're wanting to increase it by 10%, and so that multiplying by that 1.1 is going to do that for us. And similarly, we want to decrease or reduce the amount of blue by 10%, so we're multiplying the blue value by 0.9, placing those numbers back into the red value and blue value variables. If, on the other hand, the red value is not less than 63, then our next step is going to be to ask, is the red value less than 192? So that would be looking for this middle part. We know it must be equal or greater than 63, but is it less than 192? And so we pose that in an if statement. And if that's true, we're going to increase the red by 15% and reduce the blue by 15%. So multiplying by 1.15 and multiplying the blue by 0.85. If that's not true, we've eliminated two possibilities. We know it's not less than 63. We know it's not in the middle range. So therefore, it must be on the higher end. And so in that instance, we are going to increase the red value by 8%. So we multiply by 1.08. But then it's possible, if the red value was a very large number, when we increase it by the 1.08, we might actually generate a value more than 255, which is the maximum. So we put another if statement to check that condition, and if it is, we simply set the red value to 255. And then, as usual, the blue value, we multiply by 0.93 to reduce it by the 7%. Any particular pixel has to fall into one of those three categories. Either it's less than 63, it's in the middle, or it's greater than 192, in which case it falls into the end. So we've always calculated a new red value and a new blue value. So here at the end of the program, we do set red of pixel using the newly calculated red value, and we set blue of pixel using the newly calculated blue value. And that's it. That's what it takes to convert the picture from the color to the sepia. We first convert it to grayscale, and then we get the red and blue values and go through and see which category it falls into so we know how to do the math, and then we set the values. So let's run it again with a different picture just so you can see the outcome. I've got the picture, make picture, pick a file. Let's see. Let's kind of scroll through a little bit here. Let's see what the old Greek structures might look like here. And just so we can explore that ahead of time, that came in off screen, so I'm going to drag it in. Let's run the sepia tint program, and we will explore the picture again. Let me get them both pulled back in here so we can see them. Obviously on the left is the original, on the right is the sepia tint. So obviously there's nothing special about this code. It will work with any picture we throw at it. So one thing I want to highlight though, and you may have noticed in the middle of the code here, I have a comment saying that this can be collapsed. Notice the situation we have here. We have an else immediately followed by an if. We can combine those lines into one and restructure some of the indentation a little bit. In Python we have an if statement, we have an else, but we also have an elif. E-L-I-F. So let's actually combine these into one. I'm going to delete this middle part and have elif. Red is greater than, or red is less than 192. We're still going to do the same things, but I'm going to fix the indentation because it's indented too much. And this else actually will come out to here. And these all come over. And so we would have that. It's functionally still the same code. It's any particular pixel is still going to take the same path through it. It's just a shortcut, so to speak, where we can, if we have an else immediately followed by an if statement, we can combine those into the elif, and that reduces the need for the indentation. So it's a little easier to look at. And for some, maybe a little more obvious what's going on instead of having the nested indentation. But it's still going to get the color, see which one of these is true, and then set the color. So, as always, take a look through the code one more time, see if it makes sense, think about it. If you still have questions, reach out to me. I'll be glad to talk with you. We'll see you in class.